morning, everyone.
听到
Today I want to complete 2.1 pressure liquid. Before that, we already mentioned about the formula. P equal rho Hg. Make sure you know this one formula how to come. Okay, normally the pressure for the solid P equal force over area. Okay, for the liquid, we cannot using this one formula because we don't have any certain area. We're using pressure for the liquid, depend for the density, depend for the depth of the liquid, and also the gravitational acceleration. Okay, unit Pascal. You also can write Newton per meter square. This is normally we use for the liquid pressure or pressure unit. We got two of the factor that we are causing the pressure for the liquid. First one must be the depth. Number two, there must be the density. Remember, the liquid pressure does not depend on the mass, volume, surface area. This one is one of the activity you need to do it for the project. To pass up about this one, the greater the depth, then after that you find it, the pressure should be increasing. The distance further stand for the pressure. We're using the distance, you measure the distance how many cm. That one is stand for the pressure is how big. This one depth, this one is a different of the depth. Depth is count from the top until the bottom. See the depth should be increasing. After you find the pressure, the distance per out for the water should be further. The one is pressure height increase, pressure increase. Next one should be using the manometer. Okay, normally the manometer can show about the pressure per cylinder. Okay, when it just in, then you find the depth is how many lah. You set by the depth. So later you can find the liquid, the YouTube liquid. We put the color. You can see the different depth. So that means when I put lower a bit, so you can find this one color water will go down, it will go up. When I just go up, another side go down, so we measure the differences. This one different. This different, we call it as a depth of the water. So H rho G. So this one is a H lah, different depth. So density depend the inside the liquid is what is a D, and also the gravitational normally is 9.8. Excuse me. So you don't misunderstand the density is this one liquid. The H is one no. The H is depend for the YouTube. Okay, this one is no. This one is a depend for the depth you go to how many. So at the difference between the water level in the manometer, say the YouTube, we label as a D, increase as a depth of the H. So that means if I plot the graph, H and D, suppose it's a directly proportional. Okay, so this show that the pressure in the liquid P is increased, okay, increase with the depth. So the D now is a represent the H rho G. So when D just increase, everything also increase because the rho is a fixed rate. G already fixed in the manometer. Okay, so this one is a related depth. Now we're going to see related with the D. Okay, now the depth is the same. Okay, but I'm using different density. So oil, another one water. So I find it the oil only distant short when it just pop. Okay, how about the water? Water is further. So further stand for the pressure is stronger lah. So the higher the density, then the higher the pressure of it. So P pressure also directly proportional to the density. So this one, okay, both also not P. One is a P pressure, that's a rho. Okay, so this one is a second factor, make the liquid act equally in all directions. So from here you can see the twister funnel. When you put at this part, you put like this, you put this shape, go up or to left. If the level is the same, the pressure is the same. So pressure at any direction, but the level is the same. So you find it, the pressure must equal same. So I don't care what is your shape lah. Bottom, liquid no changes, and the level is the same. Your pressure must be the same. So for the liquid, the pressure at the point within is varies of only with the vertical depth or point below the surface of the liquid pressure. So you can find it example like this. I put the liquid all inside. Okay, then you see this one must have as this incline, but the level I find it same. So the pressure here, sure atmospheric. If I put here bottom, so my level is the same. Okay, the atmospheric.
SPM 考试即将来临，你是否感到焦虑？因为感觉自己的进度落后了？
在课堂上，你全神贯注，但有时候听不懂老师在说什么，特别是中4、中5的物理课。别担心，你并不孤单。现在，你急需一位既有经验，又懂得用心教学的老师，而且这位老师还能流利使用华语进行沟通，让语言不再是阻碍你取得好成绩的障碍。幸运的是，我们正好有这样的物理老师，他拥有多年的教学经验，并且在 YouTube 上有自己的频道，全马来西亚的学生都可以从他的课程中受益。如果你真的想要学好物理，那么不要错过这个线上 SPM 物理课的机会。通过这个平台，你可以更快地掌握和学习物理知识，为 SPM 考试做好充分的准备，最终取得令人瞩目的成绩。别犹豫了，赶快行动吧！与这位经验丰富的物理老师一起学习，让学习变得更加高效和有趣。相信自己，你一定能够在 SPM 考试中取得优异的成绩。
Everybody also same. So that means now at the bottom, all the pressure is the same. For atmospheric, you also got the depth of the liquid, that's a H rho G. So P here, all the pressure is the same. Why? Because the level is the same. Okay. So pressure in the liquid does not depend on the shape, size of the container, or area of the sea. Don't care about that. Just the level same, then that's the same. So pressure depends only vertical distance. So that means see the tube, test tube, they already sang it. That's sang it. We cannot count like this one. This one H is wrong. So we count vertical height. So when the vertical height is the same, so your pressure must be the same. So the pressure at the A is the bottom, B also is the bottom. So it's 8 because the water level is a. Okay, now we're going to see the problem solving. Okay, now see the liquid first one, liquid X. First situation. Okay, when first they only got liquid X. So up is what atmospheric. This one also atmospheric. So equal lah. Same level pressure. So now when I add a liquid Y, liquid press, then the liquid X up. Okay, so now the Y and X cannot mix together. We separate. So when you see this one situation, first step, what you need to do, draw a line to separate two liquid. Okay, then we look above. So you stand here, you look above. Above is what? So A, that means pressure A is what? Pressure is atmospheric plus liquid H1 low G. Okay. This one is a liquid. Okay, how about the pressure B? Pressure B also is atmospheric plus G. Okay, this one is stand for liquid Y. Okay, so this one is what we can understand when we separate the line. Remember, don't separate the line is a different. Draw here. I mentioned already, same level, same pressure. So I can say pressure A equal pressure B. Okay, so now I put in atmospheric and atmospheric support, we can cancel lah. Both sides also is atmospheric. So I write H1 rho 1 G. Now this one for the X equal H1 rho H2 rho 2. Okay, for the liquid X equal H2 rho 2 for the liquid. Okay, so this one is the equation. You want to do the calculation like the manometer or you say YouTube. Okay, I just want to ask, you can see this one two diagram 两个 diagram liquid Y 比较重还是 liquid X 比较重 Okay, anybody here can answer me? D can answer or not? Which one is more heavier, X or Y? Okay, why they say Y? Because you can see the Y can push the X go up. Okay, so that's why the Y is more denser 咯。它可以推到那个你走到这样高。OK， 平时如果你没有放，它们是平的嘛，只要我放一个 Y 下去，它比较重嘛，它就可以推。So Y, liquid Y, the density should be higher. Excuse me. Another situation you can compare like this. Okay, this one is my equation. Okay, H1. You see the H1 is longer, is it? 它很高，大的咯。H1 higher. Okay, H1 higher. Okay, another one, density one should be lower 咯。一上一下的，我们要 constant 嘛。Okay, 另外一个 side H2 很矮罢了。Okay, density 一定要 okay, understand So that means when you find the H1 is longer, sure the density is smaller. Okay, another side H2 is shorter, means the density should be higher. Okay, 它们是一上 inversely proportional. So that's why they become constant value both sides. Okay, so this one is how we want to find out either density, either you want to find the height by using this one formula. So the G we ignore. Okay, we're using the G. Okay, let's see this one. The formula P equal H rho G is used to the pressure at the depth of the liquid. Only liquid, not relate for atmospheric when they just mention H rho G. The surface of the liquid also experience the pressure. So if the question say the actual pressure experienced the object are actual pressure. So actual means you need to add atmospheric 再加 liquid. 除非它只是讲 what is the liquid pressure, then you're using this one. Okay, if the question say actual pressure, then you need to get atmospheric plus your rho G. That one is the actual pressure. Okay, now we're going to see the first question. If the density of the water, okay, you write the info. What is the pressure due to water, only due to water, at the bottom of the swimming pool, 2 meter depth. So swimming pool, 2 meter depth. Okay, so we're just using the formula for the density, height, and also the gravitational. Gravitational, we're using 9.81. So what is the total pressure acting by the water only to the bottom of the swimming pool? So Anna can give me the answer for first question. Okay, we make sure the unit is the same. If the unit is the same, you can straightforward to multiply. Okay, and the rest you get answer. You can get answer, then you can type inside the chat room. Okay, then later we can check which one is correct. Okay, you type inside the chat room. Okay, 19620 Pascal. Okay, prepare your calculator. When I just call your name, so you just type. Okay, number 2, given that the density of the mercury. Okay, density for the mercury. The pressure of the mercury at the, okay, pressure of mercury. Only pressure of mercury at the 40 cm from the surface of the mercury. So still the same, P rho G. But C, be careful. This for H, you need to convert lah. Okay, 0.4. Okay, after that, density for the mercury, then 9.81. Okay, prepare your calculator. Okay, just there. Okay, Ahang, you finish type, Yeah, correct. That one is correct. Okay, this one question 2 answer. Okay, fine. 3366. 3366 4P. Okay. Then we go to number 3. Okay, diagram show about the fish in the water. Okay, density of the water. Okay, this one density water. Surface area of the fish A, 300. Okay, this one is 300. Okay, cm squared. Okay, another one is it's a 2000. Gravitational provide 9.81. Atmospheric, already, so that means you need to count. Okay, first one, the question asks the pressure exerted by water on the fish A. Okay, by water to the fish A. So we just apply pressure rho G. So the H is a 2 meter. Okay, for the water, 1.25. Then multiply 9.81. Okay, so Aheng, what's the answer? Aheng will come in, is it? Okay, 20110.5 Pascal. Okay, so we finish for A. Okay, B. B, they ask about the pressure and also by a water on the B. So they want, okay, Yin Hong, what's your answer for B? Fish B. Okay, Yin Hong, what's the answer? For this one, actually, we don't need to do any calculation because fish B is the same level. So when they're the same level, density is a liquid. So should be the same lah. So the answer we still copy from the just now. Just now, I can give me 20110.5 Pascal. Okay, no need to show, only just answer. Okay, now C. C, the force. So force must related with the area. We're using the original formula lah, F over. Now they say exerted by the water on fish. Okay, I find the force. So pressure I know radiation is a 20110.5. Okay, then equal force. I don't know. Okay, for the fish A, surface area. Okay, surface area is a cm squared. So what you need to do, you need to convert. Okay, you need to write 300. Okay, divide by 100 is it? You want to change become meter. So you -2 because got square. So should be 4 lah. Then divide by 100, divide by 100. So you become meter squared. So your force become, answer for the force. Okay, Shermaine Go. What's the answer of force? Okay, 603.315. No Pascal. This one is a force. Should be Newton. The question asks about the force. Okay, this one D. They want to find for the B. So it's the same thing lah. 20110.5 equal F. Okay, but now 2000 10 power -4. So force equal to the Cindy Wong. Okay, the answer the surface area different. You cannot say the answer is the same. The answer is a 4022.1. Okay, so the force acting to face area for the fish B should be the big. Okay, because the surface area. Okay, so now we're going to see E. Okay, E, they want to calculate the actual pressure acting on the fish A. So we just take the pressure from the liquid first, 20110.5 plus atmospheric. Okay, so the atmospheric is 100 K. So it should be 210.5 plus 100 K. So it should be how many?
2010.5
对吗？
OK 了呀，2010.2010对，看呀。
Okay, adding 对吧？ Okay, just press your calculator only and you add together. So this one we call actual. Okay, so this one is the answer. Then we go to the one. So we just add about the atmospheric and also the H rho G. Okay, now we see the number 4. 可以啊，有问题跟我 stop 啊。Okay, then we go to number 4 already. Number 4 is the dam. Okay, see near the seaside. So you can see at the top one, they make it thin. Okay, 比较瘦。Okay, 到底的时候比较粗because the pressure here is very high. 你越深是就会越大。So at the bottom 的时候，他们会做到比较 thick 的量。Okay, so from here they can withstand the water pressure. So you can see this part only 0.8 depth. This one is a 3 meter. So the question, they find the difference of the pressure for the point A and point B. Method to do it, 你找这个 pressure 先，你再找 pressure 你减，或者是你开始就减轻都可以。Okay, we straightforward 3 minus 0.8. This one is my H lah. Rho liquid is a 1050. Then after that, G. Okay, then we straightforward get the answer. Okay, so we go to us. Okay, type in the chat room what is the final answer. Okay, 22661.1 Pascal. Okay, so this one is the differences. Okay, then the next one is find the pressure at the depth 20 meter in the water. When the atmospheric pressure, okay, they tell you atmospheric pressure, then the density of the water. Mean the question say they want total pressure. Say find the pressure, then they will sure. So we need to put rho G plus atmospheric. So 20, so you just put 20. Density for the liquid 1000, 9.81. Then you go to plus 10, 100,000. Okay, so the final answer, we get it 1196. Is it? My answer here different. The others? 11对吗? Okay, I don't get actual pressure. 他只讲 find the pressure of the depth. Okay, 他没有讲 the pressure. 他讲 find the pressure on the depth 的意思就是全部，他不一定要讲 actual 的。Okay, 除非他 mention 讲 water pressure, 这样我们就要 specific 一点。Okay, so this one answer 2.962 times 10 power of 5 Pascal. Okay, remember the question. Sometimes they want total pressure. Then just say find the pressure and then they give you atmospheric. Okay, if they want to find the water only, they must find the water pressure. Okay, number 6, we start with the YouTube. Okay, now they start with the liquid, tea, and also the water. So better step, you go and draw the line first. Where the two liquid different, we're going to draw the line. Okay, after that, you look above your equation. Okay, look above, write your equation. So from here, first step, okay, we label A and B lah, simple. So write your equation. A is what, B is what. Okay, for the A, pressure for the A. The atmospheric lah, support atmospheric, we cancel each other lah, both sides. Same. So we only got rho G, water. Okay. Then the pressure for the B, H rho G for the liquid P. Okay, same level, same pressure. So I put H rho G equal H rho G. G cancel. So we got H. H is 10 cm. cm and cm, we don't need to cancel each other. No need to change become meter. Because that also cm. And density, they say given the density for water, 1000. So I put 1000. Okay, equal height here is a 12. Okay, then Okay, so from here, they call you to find the density for the liquid PE. So from here, you find for me what is the rho now. Okay, find and you can answer this one. Okay, 833.33. Okay, unit. What's the unit density? Remember, the unit for density is a mass over volume. Kg mass -3. And what called no S. Kg -3 only. Kg meter -3. Okay, so it's a density unit. Okay, we see the question. Okay, they already draw for you two liquid. Okay, one is a liquid X, one is a liquid B. Okay, which are not mixable. If the density for the X, okay, and Y are, okay, they give you the X, the Y 800. Okay, now they want you to find is a H. So it's still the same level, same pressure. So H rho 1 equals to rho 2. I should answer the G. So H is a 10, density is a 1200. Okay, 2 I don't know. Then I put the density for the liquid 5. Okay, so I just want to know the height 2, the H lah. Okay, so from here, this answer, okay, 50. Number 8, the figure show about the cross section of the, so you can see the dam. Upper part is a thin, okay, lower part they make it become thicker. Okay, reason is to withstand blood pressure. Okay, because the blood pressure is very high, so they must make it become thicker. So if you say, oh, I build all the thicker kind of, actually kind of, but you waste the money. Top, the pressure is less one. No need the wall, only the bottom. So from here they say the density of the water in the dam. Okay, density provided. Calculate the pressure and how you can see here. They say pressure water, okay, for the water only. So that means we just take the meter lah. Pressure 4, then the density, then the 9.81. Okay. So from here, Fankai, give me the answer for this one. Okay, 39240 Pascal. Okay, and okay, so we continue with, okay, compare. This one's a compare question. Pressure A and pressure B. A is here, B is here. Sure, pressure is bigger, pressure B bigger than the A. Okay, compare the pressure at the B and the D. Okay, the answer is equal. Compare A and C. B and D. A and C also same. Okay, then the next one is set the pressure to the water. Due to the water. Okay, then they were touching about the atmospheric. So they just want the B only. So from here, we just calculate the B here already is a 2 meter. Okay, so the pressure equal, multiply the density for the water is, okay, the never provide. Okay, never provide. So suppose must provide it. Okay, there's 1,000. Okay, density for the water. After that, 9.8. So the answer for the donkey. Okay, for the donkey. Yeah. Okay, answer for the donkey is how many? Chen Yunxian just come in. Answer? Still D. Okay, so 96. Okay, Pascal. Okay, 96Pascal. Okay, if the water in the system they're replaced by the paraffin is an oil, is affected the pressure at B. Okay, paraffin is an oil, so paraffin, okay, density less a bit, pressure should be decreased. Okay, pressure at the B decreases. Okay, already less. So this was the answer for the E. Okay, just let you know the paraffin, the density is 0.79 to 0.94 gram cm cube. This one is the gram per cm cube. You convert, become the kg, multiply. So I try to multiply 0.79. Okay, we see here 0.79. I convert, become kg. Okay, then I divide the 1 cm cube. So that means it's 1 times 10 power 4. Okay, 7.9. 7.9. Okay, 0.94 by 1,000. Okay, then divide again by the cm square. 1 times 10 power negative 4. 9.4. So that means the paraffin like this only. Water already go to 1,000 kg per. This one is a water. This one is a paraffin. So paraffin is very light one. So I find it when the digit small, the pressure also decrease. Then we go to the next one, question 10. Okay, question water tank. Okay, diagram show the water supply to the block of the flat. Water flow each one unit. Okay, for the flat due to the water pressure. So water tank with the height 3 meters is fully filled in the water. Okay, 3 meters. Then calculate the water pressure at base of the water tank. base of the water tank. Okay, density is provided. So we calculate it. 3 meter multiply 1000 multiply 9.81. So this one's the water tank. At the bottom, I just get 29430 Pascal. So this is on the diagram. Compare the water pressure P and also the Q. Which one water pressure is bigger? Anybody here can tell me? Okay, so you tell me P and Q. Which one water pressure bigger?
Of course it's Q.
Okay, because we count by different depth. Okay, from here at the top, you until P, you only less meter. If I count until to the Q, you are big different. So from here we answer pressure Q more than pressure P. So you write full sentence. So you write full sentence, you just don't write P only. We don't know what's a P. So you write pressure Q is more than the pressure P. Then explain your answer. So your answer is what? Why? Depth, water depth, or you say height. Okay, height of one height. You say different depth. So we got differences. Different depth of the Q, and also the Q is bigger than the P. Okay, different depth. Okay, finish this. Go to the application. Where normally to use this one pressure. Normally, I will add our daily life we use this one, but we not realize is it the water pressure or not. So the first one is your HANA. Normally it's a tank. Okay, where's the location for the water home? Normally we put at the top part lah. We never put at the bottom, is it? So we put at the top. Okay, normally at the roof there. Okay, explain why. This one can become one of the broad question. They just show you one of the diagram. They ask you, why your water tank you want to put at the top at the roof there for what? So you need to explain. So from here, you must say you place at the base, there's a between the ceiling and also the roof lah. That means the high position, put at the top. So you must say the different height between the water level in the tank and also what? Water slide, just now diagram lah. Different level from the water tank until the water tank. So if got big difference, that means you produce high pressure. Then after that, if you got high pressure, so the water flow, high speed. So this one is your explanation. Okay, second one is the patient. They're receiving the intravenous drip. Normally you put at the top, is it? You don't tell me yet. Put at the bottom. Put at the bottom, that means later your blood come in. So from here, this one intravenous drip. They must put at the higher level from the patient. Then after that, a bag for the intravenous liquid is placed at the position. So you must say higher than the patient. Okay, when you put higher, means the pressure is due to the height. Still using the word different height of the liquid column, you push the intravenous liquid into the patient body. So from the high, they flow to the low. So the rate of the flow of the intravenous liquid in patient body depends for the height. Okay, you got how many height, that means the pressure to be increased. Okay, you want how fast the flow, this one depends for your adjuster lah. So some want slow, you want more drip to go in the body, you want slow, they come out also can. So this one depends for your adjuster. But the pressure is depend for the height. Different thing. So this one is depend for the height of the bag, and also you can control by the adjuster. Sometimes you at the low, but the pressure you can control the adjuster, let the liquid inside the inner come out faster. Depend for the pressure, depend for the adjuster. Right? Important, don't put water. Okay, this one is a dam lah. Normally they will ask about the dam. Hold the water at the high altitude. Explain why the wall at the base thicker. Why the base you want to create more thicker. The wall of the dam is built by thicker at the base of the dam because water pressure increase with the dam. I mean bottom, the depth is higher. So water pressure should increase. So the thicker section of the dam is able to withstand high water pressure. So your thicker reason you want to withstand the high water pressure. So the penstock is at the lower. This one is a penstock. Okay, at the lower. This one is a general electricity. Lower section, so the high water pressure will produce fast flow of the water to dry the turbine. So from here, the turbine must put at the bottom one. Cannot put at the top. You put at the top, the water pressure not strong. So they must put at the bottom. Then the water pressure is very strong. Then they just go in. Your turbine can turn faster. When they turn the faster, that means they can generate electricity. Okay, and the one is a siphon tube. This one is one of the application you can using. Transfer the water from the aquarium, go to the pail. Maybe you want to change the water dirty already. You want to change, become the cleaner. So explain how use a siphon work. So the siphon is used to transfer the water from the higher region to lower region. Okay, sure, the higher from the A, they flow B, C, and come down lah. You don't tell me D go to A, no. Right? The pressure cannot flow from the lower part go to higher part unless you pump. This one is the original. So one end of the tube it must fill with the water is placed in the tank, okay, of the water at a higher position because you want to create different height. So one must be put at a higher position, another one must be lower position. This one pressure should higher, this one pressure is lower. So from here, the flow of the water from the end of D produces a region of lowest pressure at the point B. So this one, higher pressure. When they go up, they flow until the D. This one is the lowest. Atmospheric pressure push the water into the tube at the A. So A, how come the water will suck inside the siphon? Because got atmospheric pressure. They press the tube A. This is A. Atmospheric, they push. After that, they up until B. B flow already. So from here, and D produce a region of lower pressure at the point B. So remember this one siphon tube. When they will stop? When this level and this level is the same lah. Sometimes you not so higher, you put a pail here. Okay, so until this level, no more already. They stop. So you want more water to come out, you put lower a bit. Okay, so this one is how we go to make the water can flow from the higher to lower. So this process we call siphon. The tube you put in like this, we call siphon tube to flow from the high to lower. So you want the more water to come up, then you put your pail, it's more lower part, or you put the aquarium, the box, go higher part. Big difference, that means the water can flow fast. Application. Then we're going to see the problem solving. Now you can see the problem solving here. They show you the cross section of the pool. You got 5 fishes. P, W, X, Y, Z. Density of the water provided. Atmospheric pressure provided. Gravitational, they say using time. First one, state the pressure experienced by the fish. V got what pressure acting to the Kerchin? John Kerchin, can you tell me? V, fish V, acting the pressure. What is that? Fish V, yeah? Yeah, atmos. From here, you scan. Example, the question says state the pressure experienced by fish. Actually, they say state. State actually the name lah. If you scan, I say, if you scan, you can write atmospheric pressure. Or you comma, you write 10,000 Pascal. Both answer you also put. Because I don't know, suddenly you want number. Suddenly you want the name. How I know? Better, both you also go to put. Then you are safe. They say state, maybe they don't want the name, they want the number. Better we write both. B, calculate the actual pressure acting on the fish Z. Fish Z, they give you the depth already. Yeah? So they say actual pressure. That means you need to add about the atmospheric. So the B, H is a 3.6, density 1000. They say using that. After that, you need to plus your atmospheric. So the final answer, pressure at the fish at the Z. Aheng, answer, how many 0? 40, 30. Okay, 1.36 times 10 power of 5 Pascal. For the fish Z, C, which one fish experiences the same pressure as a Z? Yes, indeed. Which one same as a Z? Which one fish? X, because same level. Okay, same level. There's a reason. So answer, same level, same pressure. Same level, same pressure. You want same level, you say same depth lah. When the depth is the same, the level should be the same. So we go to question number 2. Okay, with the 2 type of the divisible for the liquid. So draw the line to separate 2 of the liquid. Then the density of the liquid X. Okay, 9 to 0. Now, we compare the density of the liquid X and liquid Y. You see X and Y, which one stronger? Which one stronger? You go to ask Yun Xian, which one stronger? X stronger or Y stronger? If you don't know how to see stronger or weaker, you see the H. This one H is higher. This one H is smaller. Understood? This one density how? This one density how? It should be inversely lah. When you see the height is bigger, the density is the balik. Answer is, this is X. This one just now the question. Oh, Yu Xuan, what's the answer for question 2? Which one is denser? The Y denser. The Y denser. Because this one H already is smaller. This one should be here. This one should be smaller. That's why you can see the liquid Y can push the liquid X go to higher level. That means X is a less dense lah. Y is dense. That's why they can push. From here, we go to answer. A density, Y bigger than Y is bigger than the X. Explain your answer. So you can say the answer here. I write here. Shorter coulomb of liquid I can support a higher coulomb of liquid X. Mean the liquid Y only using the shorter coulomb. Only using the height 9.6, they already can support the higher coulomb. There's a 12 cm of the liquid X. That means the liquid Y is denser compared to the liquid X. The B, they want to calculate the density of the liquid Y. So we just put 12. This one is the liquid X, 920. Liquid Y, 9.6. Density, don't know. I want to know density for the liquid Y is how many?
3,150 kg per meter. Meter cube.
1150 G
Per meter.
and 3. Correct. In home correct. So this one is a question number 2. Then we go to continue for question number 3. Question number 3, then you see a ball bearing that emerged in the water. State 3 different ways. I want to increase the water pressure on the ball bearing. I want to increase more pressure. Atmospheric pressure already is a fix. You cannot increase already. Then you only can increase the depth lah. So the first one, increase the water lah. How to increase the water? Add water lah. Add the water into the water. So I mean the depth will be increasing if I add the water. Number 2, I put the ball bearing go down a bit lah. I go down until the bottom. So I mean the depth already increased. Third one, you cannot say you change the water. The question never say you want to change something. They just say how to make it. You want to add something. But you cannot change the whole thing. You cannot say, oh, water I take out, then I put in the mercury. Sure, different, like this. But the situation, you only can add. You cannot through and change and back, come back. So up here, the first one, I say, lower the ball bearing to greater depth. Lower, that means I create greater depth. Number 2, I say I add water. I add water into the, when I just add the water, the depth also increase. Number 3, density. Density, we cannot change the liquid. So you only add something. How you add? You add the salt. When you add the salt, density also increase one. Say dissolve some salt. It becomes salt solution already into the water. When you just add the salt inside the water, they become salt solution. Density will be increased. So it's how we go to increase the pressure acting to the ball bearing. And the last one only want to sketch a graph. They show about the metal block lower into the water. Now P is what? P is the pressure. Pressure on the top surface of the block. 可以 change bigger surface area of the bearing. Cannot change anything inside. 里面的东西不能再换了的。就像我不可以换那条线，那个 ball bearing 讲大小我也不能换，它的重量也不能换，水也不能换，你只可以加东西的。So the question never call you to modify. They just want to increase the water pressure, so you need to add. Remember 不要换东西了OK， 我可以换我很多东西可以换了的。So situation we still maintain. You just add something to make the increase for the pressure. Sketch the graph water pressure on the top of the surface to the block against the depth H. I mean, if my pressure is more, how to make the pressure more? You go deeper lah. You go deeper, the pressure increases it. So if the pressure increase, you go deeper means the height also increase. How you plot the graph? So graph. This one is a head, 1 meter or cm, normally cm. This one is a P, Pascal. How about the relationship? The relationship is directly proportional. That increase, pressure increase. This one is the last question for the topic 2.1. Anything you want to ask me? 东西要问吗？我们还有时间我们继续去 2.2 了If this one no problem, then we can go to 2.2. 2.2 is the atmospheric pressure lah. Just now we got touching about a bit atmospheric pressure. So in 2.2, you're talking about atmospheric pressure means every question you need to add Just now only is water. Now you're going to see atmospheric pressure is a pressure. This one is a definition. When they ask you what's the atmospheric pressure, the pressure due to the weight of a layer of the air acting on the surface of the earth. That means the weight of the air. Air also got weight. Weight of the air acting to the surface of the earth is called atmospheric pressure. Characteristic for the atmospheric pressure depend for the altitude. From here, the first one, decrease with the altitude. The atmospheric pressure changes according to the altitude. Altitude is the height of the above the sea level. So now this one is a normal height. When I just go to the mountain, you go to the deep sea, so you find the pressure is different. So here they say greater the altitude, the lower the atmospheric pressure. 越高 atmospheric pressure 就会越低。So equally in all direction. The atmospheric pressure anyway also got. 你不要跟我讲你躺住你没有 atmospheric， 有，不管你坐住、翻住、跳住都有。Anyway also atmospheric pressure and acting equally. 没有讲你躺住你坐住比较多一点，没有一样。Any location also got, and also there's an equal. Atmospheric pressure acts equally in all direction for every object in atmosphere. Any object, they're also acting by the atmospheric pressure. Atmospheric pressure standard 10,000 Pascal at the sea level. And now we are in sea level. Normal level, sea level. On the surface of the earth, atmospheric pressure can be high as this one, surface of the earth. Surface, they are inside. This one is a surface. So value of the atmospheric pressure we calculate by first mercury barometer. So that's one first equipment. We need to know how to measure atmospheric pressure. So atmospheric pressure, the first one we mentioned already, depend for the altitude. So go to Gunung Kinabalu, that one is a high level already. It's a low atmospheric pressure. So go to the deep sea. Diver, they go to the deep sea. That one is pressure is very, very high because you go to deeper part already. You add the water pressure, add atmospheric. So mean your pressure should be increased. But go to the high mountain, the pressure is low. Why the pressure is low? Because related with the temperature. Temperature low, that means the collision with the molecule become less. So create the pressure become low. So that's why when you take the plane, you go fly up, you find it, your ear got pressure to act for your ear. That one is because of the difference of the pressure. Or you go to the Cameron Highland, Genting Highland, just up you find your ear is difficult. You feel very pain. Very pain means the pressure level changes already. So you find different already. When you come down also same. So already biasa at Genting Highland, suddenly you want to come down to sea level. So in the pressure acting to your ear also different. So to come back to the normal, you also find it, the pain. So that is one of the reasons why you feel the ear is different, difficult to feel it pain. This one is something we never realize. What is that? I don't know. This one is a reason. Physics every time acting to our body, our daily life. But we do know that one is a physics. This one is one of the example. Atmospheric pressure we cannot see, but we find it, we can feel what is the pressure. This one is one of the mercury barometer. You see mercury, sure the whole thing using mercury lah. They consist of the 1 meter long of the glass tube. This is a 1 meter long glass tube. They're containing for the mercury. You fill in the mercury full until full. Then the mercury column in the glass tube will remain at a certain height. You need to invert it. So this one you fill in the whole tube is 1 meter height for the mercury. After that, you terbalik, put inside the dish. Put inside the dish. The dish also is mercury. After that, you find it, the mercury column of the glass tube will remain at a certain height. They will drop. Mercury will drop into the dish till certain height, they will stop. This one is the original one, we never adjust. Until certain height, they stop already. Then this part is a vacuum part. Don't have any gas. Unless you go to blow the bubble in. When you blow the bubble in, different already. Because you got gas, then you got mercury. Your mercury should drop one because you got a bubble. So I want to create inside is a vacuum. So must fill the whole tube is a mercury. Then I bubble inverted, straightforward, put inside the mercury. So automatically will drop one. Automatically drop until certain level, stop already. So here they find it, this one is a vacuum. So atmospheric pressure acting on the surface on the mercury in the bowl supported the mercury column. Now the mercury inside the dish, They supported the just now, drop the mercury inside the tube, support until certain level, stop, no more supported, like this, no more drop. So from here, the height of the mercury column depends on the magnitude of the atmospheric pressure. So from here, you will say, is it every time they drop 76 mm? Suppose it's 1000 mm lah. 1000 mm is same like the 1 meter. So drop until 760. This one is how many? How many already dropped? It's around 240. 240 mm drop inside here. So from here, they drop until 760 mm. I just want to let you to know why they drop until 760 mm. If you bring whole mercury barometer, you go to the Genting Highland, you find it no. They will drop more. They will become 75 or 74. They cannot 760, 740 maybe. Why? Because they follow the atmospheric. Just now I told you, same level, same pressure. Here, atmospheric acting. Here, atmospheric acting. This level, we find this level. This one, what acting? This one is the height of the mercury thing. So we got 3 levels. 左边 atmospheric 压，右边也是 atmospheric 压，中间呢关注了的，但是 same level same pressure 嘛。atmospheric 是 7.6 cm mercury， 左边也是 7.6 就76 cm， 不是 7.6 76 cm mercury， 中间那个肯定也是76 cm mercury 嘛， same level same pressure 嘛。Understood? If I say this side also 76 cm mercury, this one height how many? 肯定是76 cm. This one unit 76 cm mercury. That's one of the unit for the pressure when we using mercury. You cannot say, oh, 76 cm water. If water different already, water 没有可能76了 water 很长了，因为 water 的 density 很小 mercury 的 density 很高。This one is why I say when you go to the Genting Highland, you cannot get 6 cm. Maybe you 75, maybe you 73. Because atmospheric pressure drop. When you go to Genting Highland, the atmospheric become 73 cm mercury only. I mean your height for the mercury also drop, becomes 73 cm. This one is one of the mercury barometer. They want to measure how many height of the mercury can be supported. It depends for the atmospheric lah. Important, you need to know same level must be same pressure. Now they say the mercury coulomb in the glass tube will remain at a certain height. Atmospheric pressure acting on the surface of the mercury in the bowl supported the mercury coulomb. The height of the mercury coulomb depends on the magnitude of the atmospheric pressure. 它有多高，它是 depend 那个 atmospheric 的，因为它们 at 同样的 pressure. Okay, the value of the atmospheric pressure is stated in the terms of the height of mercury coulomb. 在这边我们是用 height of mercury coulomb. If the height is 760 mm, you can put like this. 760 mm 也可以，或者是你放76 cm mercury. This one called mercury unit also can. So this one is unit mercury. If you want to Pascal, can you also convert to Pascal? Pascal is a H rho G. H is what? H is a height. But your H you convert to meter, 0.76. Density, show the density for mercury. Then you must know the density mercury. How many? This one. 1.36 times 10 power 4. Then gravity 9.81. After that, you get it. The answer is this one. This one is unit Pascal. This one unit mercury. Sometimes the question they want mercury. Sometimes the question they want Pascal. Then you need to convert. This thing we call mercury barometer. Mercury barometer. We go and see one question before I go to 14 barometer. We try to see question number. What is the advantages? Explain. Calculation. We go and check. We go and see the question number 6. Number 6. Number 6 you try to do. Number 6. Inside is no vacuum. A. They say inside got A. A simple barometer. If the air trap in the tube. Give the atmospheric pressure equal to atmospheric. Find the pressure of the trap. Yes. Then the density of the mercury is provided. They want to find inside the pressure is how many. From here, we need to know same level, same pressure. Now we're going to check this level. This level memang is an atmospheric pressure level. From here, I can write the equation. Atmospheric pressure is a 10100 Pascal equal. Here got what? This one A, B, C. You are the B. You look above. Above the B got what? You got A pressure. We got rho G. From here, A pressure, I don't know. Lo. The question I want to find. H rho G, I know H. H is a 55. Not 100, 55. I want to know this one only. Liquid pressure. 55 cm. 55 you convert become 0.55. Also, density of mercury and 9.81. From here, I can find what is the pressure. We start with the find the gas pressure. How many? What's the answer? It got 0, 0, is it? Ayo, I makan 1, 0. 1, 0, 1, 0, 1. Then 3, 0 behind. Answer? Answer is 1844. 1844. Minus what? Minus or not? How come bigger than this one? You take 10130. This one go to minus this whole thing. 0.55. 0.55 multiply 13600. 9.81. Then you go to 10130 behind. And you get 2 point something, is it? If the standard form lah, you get 2.7662. 621 times 10 power of. Get it? This one is the pressure for the air inside the tube. This one is how we go to find it. Okay? 2.7621 times 10 power 5. Okay, you can try to question 11. How 11, we're going to see the different level. This one. Find the pressure at the point A, B, C, D. How many D, D? A, B, C, D only. D, E, and F. Unit, we put cm mercury. The density of the mercury provided. That means they want you to convert and Pascal. Both are. This one I want pressure. Then the unit I want cm mercury. Another one also pressure, but I want is Pascal. We check. Okay, first one pressure A. Pressure A at the top. The question never mentioned. So this one we assume there's a vacuum. If vacuum, low pressure. How about the pressure B? Pressure B. Pressure B is how many? Mercury. I want unit cm mercury. How to write? B. Look above. Everything look above. Don't look down. Aheng, what is the answer? Okay, Aheng not here. Okay, you give me the answer for cm mercury first. So you do the calculation for Pascal.
第二个。
Okay, Aheng 不一般的。
老师，我可以回答第一题吗？
你要回答第一个 PB 啊？来讲。
是不是 59 cm per 59 cm mercury？ 这个很麻烦，这个要算。
你给我第一个对 ，din 给我17啊 ，unit 是17。OK， 如果上面写了 cm mercury 你就不用写咯，但是 support 我们再写多一次啦，因为怕你忘记。17 cm mercury， 所以 convert to Pascal， 来快点。
麻烦。
mercury 给你 density H rho G 罢了。
9.81。
22680给你。
这样快。
22680.72。OK。PC 来给 PC total height is how many? You take 59, 76, 59加17啊 ，76 cm mercury. In Pascal, faster, right inside the chat. 101 396.16 Pascal. Next, PD that means you add one more x cm. 然后打完它 84 cm mercury. And the next one is a 112069. 112069.44. Okay, you want to write standard form is okay. Just make sure standard form is 4 decimal point lah. Next one, PE mana dia? PE here. PE 跟 P 什么样啊？ Then the E and F 和 C 一样。Okay, C 是肯定一样 ，same level 吗？ We go to E and C 76咯。cm mercury, you can find this one, come down. How about 在外面 F 肯定也是 atmospheric 咯，我不管你在哪里啦，总之它也是一样76 cm mercury。这边都好，都是76 cm mercury， 因为你是 atmospheric pressure. So the answer, stand about this one. Now we go and see the next one. 刚才呢我们学了一个是 mercury barometer 嘛。Now we go and see another barometer. 总之你看到 barometer 他们是一个 family 来的，它就是要量 atmospheric pressure。 So from here, 14 barometer. 14 barometer is better than the mercury. Why? Because mercury we need to measure. 我们要算 14不需要 14它有一个 meter 给你的，还有一个 scale， 只要你放下去，它就 show 你的 reading 了。如果是这样子的话，我们就没有出在考题了，因为考题是要你算嘛。14 barometer 它只是一个 equipment can show the reading straightforward. 如果 show reading straightforward, we cannot do any calculation. So we only learn about the type of the 14 barometer. Inside we got what? 14 barometer is an improved version of the simple mercury barometer. 这个会比较准咯，因为还有一个 meter to show 嘛。It measures the atmospheric pressure more accurate. The barometer tube is encased in a brass front. Then this one enable it to be carried around easily. 你带去哪里都可以量到。The 14 barometer has a height almost 1 meter 啦，1 meter 长啊，很高啊。From here, this one instrument usually used to measure the atmospheric pressure at the meteorological center, 在 center 里面量的。They got one of the ladder bag. 这个 bag and mercury pump. After that, they produce the reading. Vernier scale is used to taking the reading of extra accuracy. Vernier scale 可以读到比较多 decimal point compared with our calculation 啦。So from here, this one normally for true reading can be shown. 不适合拿来算的，它只适合拿来量比较准确的 atmospheric pressure. Next one is 这个1 meter 长啊，这个就比较小。Aneroid barometer 也叫 barometer. Aneroid barometer function is a mechanically partial vacuum metal box. OK， 它有一个 partial 一半 vacuum 的 metal box can change the size when they are changed in the atmospheric pressure. 这个 box 的 atmospheric 不一样的话，它的 size 就会变，可能压比较少。When they just press, that means the needle can be show the reading 咯。This small changes in the volume of the box is amplified by a mechanical system to move the pointer of the barometer. 只要它那个 partial metal box atmospheric 高或低，它就不同的 pressing. If you press more, that means they show the needle, the bigger reading. If you press less, that means the needle move a bit, they show the small reading. Analog barometer is suitable to be used in home, ship, and also the aeroplane because they show the quick reading 很快，它 reading 不用等 show 你。另外一个它的 size 是比较小啦 ，small size compared to the 14 barometer. But you say accurate, sure is a 14 because 14 got vernier scale 很小的 scale. Small changes they can detect. But size is quite big, around 1 meter. But this one is small. But this one can show faster reading. And now we see the comparison between the two barometers, 14 and aneroid. The first one, the value of the atmospheric pressure determined by changes the height of the mercury coulomb. Height of the mercury coulomb. This one depends for the atmospheric pressure is determined by changes the volume. 一个用 volume, 一个用 height. For the metal box. 另外一个 large size, 很大. This one smaller. Take longer time to give the reading. Maybe the mercury you want to wait. Okay, they want to show you the reading, but this one that reading can show. Okay, then just like the gas to press it. After that, they can show the higher accuracy, 0.1 mm mercury. Lower 1 mm mercury only. So decimal point is more. So that means you can read more reading. So this one's the differences. 14 and also aneroid barometer. Normally, we never using for calculation. Maybe the question come up for essay, ask you what's the differences. 14 and also aneroid. Remember the word got barometer. That one using to measure atmospheric pressure. Okay, calculation normally using mercury barometer. Okay, now you see this one. Advantages. The question asked like this lah. Advantages 14 barometer over a simple mercury barometer. Mercury is our used one. One is a 14 barometer. What is advantages? From here, more accurate lah. More accurate for the 4 barometer. Another one is 14 barometer compare mercury barometer. This one's more like it. Although you say 1 meter long, but they compare to mercury barometer, this one smaller. Remember your mercury barometer, this one tube already is 1 meter. And some more you want to put the dish, 肯定是超过1 meter 了的。它 14 barometer 肯定是小过 Mercury barometer， 但是最小一定是 Android 啦。More accurate, number 2, you can say easy to be carried compared to this one. Explain why the barometer can be used to measure altitude. Barometer, 每个 barometer 都可以量 altitude. So we go to answer. The atmospheric pressure, you write full atmospheric pressure, is inversely proportional to altitude. And the altitude can be determined from the atmospheric pressure. So from here, explain why the barometer can be used to measure altitude. 为什么我们可以用 barometer 来量高度？因为它是跟那个 atmospheric pressure inversely proportional 的。The atmospheric pressure inversely, then altitude 越高 ，pressure 就会低嘛。所以我们可以用这个 barometer 来量那个高度，那个山有多高。因为我们懂 pressure， 只要你要懂 pressure， 我们就可以用 H-rho-G 来量那个 height 有多高。So the atmospheric pressure is inversely to the altitude. So the altitude can be determined from the atmospheric pressure. From here, normally we're using H-rho-G. Rho 肯定是 mercury 咯。If you're using barometer, show mercury. And so G we know. So from here, if you know the pressure from the mercury, then you know what's the H. If you bring the 14 barometer 就会 show 你多少 mercury 多少 pressure. Maybe 76 cm mercury. Like this. That means from here we can calculate what is the height. Okay, what is the height for the mountain? Okay, we go to the last part. The last part, I just want to simple question first. We go question number 8. This one finish, we go to number 8. 周末拜拜。还有谁在哦？说我可以教的是11吧？
没有啊，我走了。
我来讲话。You observe the manometer. Observe 啊，看清楚啊。Okay, determine the pressure at the point A. 零啊，对吗？
对啊，零啊，因为上面 vacuum 真空嘛，所以没有压力。
他已经关注了，没有了的。Okay, B.
算一下啊，0.5。
B we just look above 了，对吗？看上去就好了。所以肯定是50了。
对，50你再乘以
，OK，
你再乘0.81就可以了。
And the question never mentioned they want what you need, or you want write this also can. You want to convert become Pascal, also can. 有讲要吗 ？Determine the pressure. 没有讲。
有 pressure 不是吗
？pressure 吗 ？pressure 也是 pressure， 这 cm 的 pressure。
哦。
Or you want to show the calculation, there should be 66708 Pascal 啦。不来意思啦。Okay, is pressure. So just look above again.
两个咯，76 cm Hg.
So that means there's a 76 cm mercury. Or you want to write? 来，定，快点 ，last， 我要 Pascal 了。OK， 101396.16。OK， 我还要问多一个问题 ，What is atmospheric pressure？ 老师要不要写 Pascal？
大气压力。
还是写 pressure 就好了啊？什么叫 Pascal？ 什么是 pressure？pressure 是 pressure，Pascal 是 unit， 写不可以了啊，不一样的东西啊。pressure 是 symbol，pressure 是 physical quantity，Pascal 是 physical quantity 的 unit， 好像你讲 mass 的 unit 是 kg， 不一样的东西。pressure 要写 Pascal 也要写。OK， 来给我答案 ，atmospheric pressure 应该是多少啊？
分析啊，还是整个东西？
我要 atmospheric， 你不要跟我讲那么多，我要 atmospheric 罢了。atmospheric 就是这边哦，因为它进去嘛，这 open 的嘛。
对。
所以你跟我讲多少 ？Same level, same pressure， 我就
对，所以是76。
对，它跟 C 同样 level 的，
对
，76 cm。So this one we call it same level, same pressure. So 明白咯 ？So we just stop at this one. So the rest one we continue on the Monday. So I record already. Later I share in the group 啊，就是讲后 we all can leave already. See you on Monday again. Bye.